Okay, now we're gonna find the conditions on small z to see how this number that we denote by u, which is equal to z plus 1 over z, is pure imaginary. Okay, so we know that in general, okay, given a complex number z in C, so z is pure imaginary if only if is z bar is equal to minus z. I have proved this in one of the videos. You can check it. And in fact, that's what we're going to use here. So assume that u is our z in this case. And we're going to show that u, when can we have u bar is equal to minus u. Okay? And from that, we conclude the condition on z that would let us check that u is pure imaginary number. You can stop the video here and start working that by yourself. Okay, let's solve it. So we know that u bar is z plus 1 over z bar. Okay, again, this is another property of the conjugate. So given any two numbers, z and z prime, okay, given z and z prime, so the conjugate of the addition of two numbers is just the addition of the conjugates. Okay, so I'm gonna prove this one in one of the videos. Okay, and maybe I'll do one separate video about the conjugate operations. It's becoming very important and necessary for so I'll do one lengthy video about the operations for the conjugates. Okay, let's go back to here. So using the definition, so we have z bar plus 1 over z bar. Again, so z plus 1 over z bar. So using the operation of the conjugate, okay? So again, if you have two numbers, z over z prime, and you take the conjugate, it's the fraction of the conjugate. So the conjugate of z over z bar is just the conjugate of z over the conjugate of z prime. That's what we're going to use here. So the conjugate of 1 is 1, and the conjugate of z bar is z bar. So this one, u, according to here, must equal to minus z, okay? So minus z, which is u, so should equal to minus z minus 1 over z. Okay, we are assuming that z is different from 0. Okay, so let's solve now. So we have z bar plus 1 over z bar equals minus z minus 1 over z. Okay, so let's put everything in one side. We have z bar plus z plus 1 over z bar plus 1 over z. Okay, let's multiply everything by z bar z. So multiply everything by z bar z. So you get z bar squared times z plus z squared z bar plus z bar equals 0. Okay, here we're gonna factor out by z bar. Okay, we get z bar plus z bar equals 0. Okay, again, using our knowledge of the factorization, we get z plus z bar times z bar plus 1 equals 0. Okay, so here we notice one thing. This z bar, z times z bar plus 1 equals 0. This number here is just z, the modulus of z squared plus 1 equals 0. Okay, so that means z squared is minus 1. This can't happen because z, the modulus of z is in R. So the square of a number in R can't be equal to -1. So we reject this one and we get z equals minus z bar. That means, according to what we know in this case, that means z is a pure imaginary number. That means z is equal to ib with b in R. So we found the condition that would make this number pure imaginary. Okay, so that means the z can be written as in this form. We'll check it. So let's check it. Let's check that u which is equal to z plus 1 over z is equal to minus z minus 1 over z. Because that's the definition. So let's see here. In this case, what we have u equal ib plus 1 over ib. If we take the conjugate of u, so it's going to be minus ib minus 1 over ib. We take the minus out, we get minus ib plus 1 over ib. And this is what? Just minus u. Okay, so that means we have u bar equals minus u. And this, we verified that this is just a verification. We have already found the solution for this problem. The z is ib. Okay, that's to make this number here pure imaginary, z has to be pure imaginary. Okay, we found the solution, which is this one, and we checked that it's the right one. So that means the set of the condition that would make this one a pure imaginary is that z can be written in this form, or we can say that z is just a pure imaginary number. That means a is 0. Okay, you can check it here, or you know this one from your knowledge that z bar is minus z if only if that z is a pure imaginary number. Thank you.